Screen recorder does a little beep, beep, beep. It's fancy. I like it. Okay, so even as these get hard, so there's a lot of different ways you can ask these questions in this chapter. It really boils down to just a handful of ideas, but there's so many different ways to test you on it and to assess you on it that it becomes hard, but it really does kind of boil down to these 4 blanks, okay? So in terms of the quiz, be able to do a relative max and a min by checking your signs with or without your calculator. So without a calculator, you're going to set up your sign chart, should factor nicely, do your signs. If it's one of the ones you can't factor or you can't set equal to 0 and solve, be able to do it with your calculator. Same for the concavity stuff, all the second derivative information. And then really, again, like I just said, it all boils down to really these 4 ideas. And then everything is based off of these things. When the first derivative is positive, what that tells us is that our function is increasing, which then obviously means if the first derivative is negative, that tells us that our function has to be decreasing. That's really no different than something you've been dealing with for a long time with lines. If your line had a positive slope, the line was going up. If the line had a negative slope, it was going down. We also talked about the second derivative. If the second derivative is positive, that means you are concave up on the original function. And if the second derivative is negative, you are concave down. A lot of different variations, but it all largely boils down to those 4 things. All right, then the derivative of function, we talked about this in the last chapter. The reason we bring it up when we started sketching these curves out the other day, these started to pop up again. Our derivative will be undefined. So if we ever do a little sign chart and we test a number here because that makes the derivative undefined, then that would have to mean that your original graph has either a discontinuity, a sharp corner, or your graph goes vertical, giving you a vertical tangent. Right. And then the last thing, and then pretty much every question is based off of these ideas. Maximum and minimum values can occur only at the following 3 places. Endpoints are the most obvious, if you have them or not. And then the other 2, these other 2 are grouped together. If you ever hear the words critical points, which we talked about, that is defined as when our derivative is 0 and when our derivative is undefined. All right, so now let's go through some of these. Number 1, we did one of these on Friday when it said find the absolute maximum and minimum values of. So first thing I want to talk about, make sure we get, so you don't miss this. I am asking you to find the absolute maximum and minimum, and it says values of f of x. So the ultimate answer to this question is your largest y value and your smallest y value. So 1, know what I'm asking for. Am I asking for x's or am I asking for y's? When it says values of f of x, that means we want our functional values. So this is now going through, this is when we list our candidates. Again, very appropriate for tomorrow, in terms of what could be our absolute max and what could be our absolute min. 2 candidates for sure, because we just listed them above, are your endpoints. So the x value of a -1 and the 4. But then we have to test our critical points, is when the derivative was 0 or undefined. So we would take the derivative. It's a pretty simple little derivative to take. 6x squared, 6x. Look to see if it's undefined. We've dealt with a number of them that are, and if that's the case, you would write it as a candidate. In this instance, though, there's nothing that's going to cause an issue here. So then we can only set that equal to 0, and then we'll pull out the 6x. When you're looking for values of the function, doing a sign chart really doesn't give us much information that we need to know, so it's rather unnecessary. What we just want to talk about, oh, it's not a 6 either, by the way. I'm thinking. The 0 and the 1, those just go in as candidates. Because what we really now need to know, if those are our only 4 candidates, then our biggest values have to occur at one of those 4, as does the smallest value. So then we just line them all up, figure out what all these values are. The biggest one's the max, smallest one is your min. Make sure you're plugging in the original function. We want functional values. So if I take a -1, we get what? -2 minus 3 plus 2. So that should be a -3. You guys can check me on that. It's -2, -3, yeah, so -3 for that one. And that's all right, and then 4, yikes, this is what, 128, 16, so 48 plus 2, so that's what, 82. I'm guessing that's going to be our winner. All right, the 0 is easy. That's going to be a 2. And then the last one we got to plug in is the 1. Let's see what we get for 1. 2 minus 3 plus 2. We get a 1 there also. Yeah. Yeah, I think so, unless I messed up. All right, so then those are our 4 candidates. We can now answer the question. Answer this correctly. They do, so I do fully expect you to give me the y value. So do not give me a point. Certainly don't give me just the x coordinate. What we want is the largest y value. So you would say the absolute max is y equals or f of x equals. Don't write f of 4 equals, because again, that's a point. They view that as a cop-out and you not really understanding what they're asking for. The largest value is the y value of 82. And the smallest value then has to be the y value of -3. All right. Okay, now these. 1, make sure you are in radians tomorrow. You would not be the first kid. It almost happens every single year with at least one person. They take this quiz in degrees, and then they miss every single one of these. All right, and then obviously the grade is really bad because every one of these questions now you've missed. So when this says use f of x, and I'm giving you that function to answer a, b, and c, once you see that trig function in there, it means you're probably going to have to graph this. Look at your graph, whether that be the first derivative or the second derivative. Know how to read that graph to answer these questions. So for number 2, a and b, where we have maxes and where we're increasing, are both first derivative ideas. So for a and b, we just need the first derivative. You still want to look to see where is that undefined. It's not, so we don't have to worry about that. Nothing makes that causes that to be undefined. Therefore, the only option then, without any endpoints, is to set that equal to 0. And then now we've done enough of these. Hopefully, we look at that and realize there's no trick here. There's no way you're going to be able to solve this by hand. So you've got to graph it. And then based upon what that graph looks like, we've got to be able to answer these questions. Okay, so I'm going to give you a minute to do this just to make sure, without me being here to really see that we're doing these, because these typically are a little questionable anyway tomorrow under normal circumstances. Go ahead and see what we get. Honestly, I probably got to do this myself. Now I think about it. I can do that in my head. Although I think the calculator battery's dead. See if we can trust Shelby in here.
Mine's in off. I don't know.
Oh, no.
I was going to ask you about it because when I do like the max thing.
Don't do the max thing. That's your problem.
That's what we had to do.
No. Because what you did is just graph the first derivative. So now what you've got to do is look to see if I'm looking for a max. It's where the derivative goes from positive to negative. So the point you want to use, or the point you want to find, is this point right here.
Okay.
So do a zoom in real quick. So here comes our derivative. See how it's going from above the x-axis to below? That's our answer. Okay. That's our max. So you have to do the 0 option. So second count 0, and that's the 0 you're trying to find. Okay.
Yeah.
So now you need to go to the left at that point.
Like all the way down?
Yep. So here's the point, so that you're going to the left of it. Okay. And now you got to get to the right of that point.
Oh, it's like not moving. Oh. Okay, and then hit enter.
Yeah, you're cutting off the course. So.
And then enter again, right?
Negative 0.438. Do we have a negative 0.438?
Because when we started my class, I've been like doing it wrong.
Don't do the max.
Probably one. Okay.
Yeah, that's the max button is the devil, Shelby. Like leads you down the path of darkness.
Mm.
You don't want to do that. Okay, so it should have looked. Let me find some space here. So I'm going to erase up here so I can draw this graph in. It should look like a parabola. I mean, obviously there's a trig function in there, but it does take on, in many ways, the characteristics of a parabola. Go like this. So it should look like this. And then what you have to understand is you are looking at f prime. And eventually I'm just going to give you f prime. Like, so tomorrow I could just give you this derivative. And all you have to do now be able to do is read that graph, whether that be on the calculator or if I just put it on the paper. This is our answer right here for letter A, because that's where the derivative is going from positive values above the x-axis. Once it goes underneath the x-axis, it's going to take on these negative values. So that dot is your answer. And that was a negative 0.438. Okay, so we got that, good. If I had asked for the minimum, then this dot is your answer. All right, because that's where the derivative is going from negative to positive. Now, if I give you the derivative graph, so let's say I just gave you that derivative graph tomorrow, which I'm going to certainly do, give you a derivative graph and ask you a whole series of questions, and I ask you where is the point of inflection for the original function at based upon the derivative graph, then this is your answer down here, whatever that would have been, because that's where the derivative, the slope of the derivative is changing from negative to positive. So be able to kind of read all these different graphs. Certainly going to get a number of those tomorrow. Then when we go to B, where is the function increasing? Our thought is, where is f prime greater than 0? Where is f prime positive? You were looking at the graph of f prime. So anytime that graph is above the x-axis, it's going to have positive values. So here is one interval here from a negative infinity to that negative 0.438 union. Anybody in here have that other one yet? Okay, so then the other one would be, is that what you got?
Yeah.
Okay. 0.7, what is it? 0.748?
Yeah.
0.748 to infinity, because that's also when it's above the x-axis. All right. All right, so then the next one, concave up, that's really a second derivative idea. So I would recommend for right now, getting your second derivative, and that we can do very quickly, 6x minus the cosine of x. Same process, look to see if it's undefined anywhere, and it's not. So set that equal to 0. Now you're going to graph that. That should not be 6x squared though, right? 6x. That should now be somewhat of a line. And then you're looking to see when is that second derivative graph going to take on positive values. All right, so that graph, squeeze that in there. Should look like this, kind of like a little line-ish. And then if that is the second derivative, which it is, whenever that's above the x-axis, that's when the second derivative would take on positive values. So your answer would be this point right here. So your calculator is going to have to give that to you. And then through infinity. All right, anybody got that in here yet, confidently?
0.164.
That sounds familiar, actually. 0.164 to infinity. Okay. Concavity is just parentheses. Yep. Be prepared for that. I think there's 3 or 4 of those on there where you're going to definitely have to use your calculator look at the graph, understand what we're looking for by looking at that graph. All right. All right. Number 3. Go ahead and answer number 3 real quick. This is something I've told you you're going to have to be able to do. Come quiz and/or test and/or AP test. So I'm giving you the original function. Which of the following 3 choices could be the graph of the derivative? Okay. And what we've talked about here is, regardless if I give you f or f prime, always ask yourself, how can I find the max or the min on the graph that I gave you? So that's how I would always approach this. And in this case, since I'm giving you f, you can take this very literally. Here's a minimum right here. That's f. So if I ask you, where does f have a minimum? We have a minimum at x equals 0. So what that would then translate to being in the derivative graph, what that would have to then mean is f prime is going from negative to positive at the x value of 0. And that right away should narrow down our choices. So if I look at A, that's going the wrong direction. I'm going from positive values to negative values. So this would actually mean we have a maximum in the original function, and we clearly do not, so it's not going to be A. But these both have that correct sign change. This is going from positive to negative. This is also going from positive to negative. So both of those are going to give us a min. So we satisfy that element. And then we just have to decide which one we're going to talk about as our final answer. So it's similar to one we did before. If I kind of go to this point right here, I have a pretty flat slope. And it looks like this guy's just about ready to flatten out up here. So that means my first derivative is just about ready to take on a value of 0 again. And the only one that does that is this one. This one is just about ready to cross the x-axis again, giving it a value of 0. And the same over here, just about ready to cross the x-axis and give it a value of 0. So it would have to be letter B. Okay. All right, next page. This one now I give you a function graph. So typically you can see both of these right off the bat. But if you look at the first top or the top graph, I am telling you that's the graph of an original function. I ask you a whole bunch of questions on it. Second set of problems, I'm giving you a derivative graph, asking you a whole bunch of questions. So please, please, please read carefully what graph you were looking at, because it completely changes your answers. Okay? So for this one, this is a function graph. This is our original function. That means, well, let's go through it. Where does f prime equal 0? If that is our function graph, the derivative is your slope. So when you see this little guy, that means we are looking for the slope of the graph of f to be a 0. So we should have one spot here, here, and then there. Those are the 3 different places where the derivative would have a value of 0. All right, if I ask you where does f prime not exist, that should be obvious, so pick that one. Shade 4, correct, sharp corner there. Number 3, name all x coordinates where the graph of f has a relative min. So let me point something out up here as well. Look at the interval I gave you. Notice how I use brackets. That means your endpoints have to be considered for maxes and mins. So when we ask this question then, where do we have a relative minimum? -7 has to be an answer, because that is a low point on our graph, and the endpoints are included. And you're just looking at it literally. Right? It's clearly a low point on our graph. The other low point on our graph, or at least another low point on our graph, is at x equals a -2. And then another low point on our graph is the x value of 4. That also shows how we can get maxes and mins, because this was an endpoint. That gave us a minimum. This is where our derivative equals 0. That can give you a minimum. And this is where our derivative is undefined. Those are the only 3 things that could ever give you a high or a low point. All 3 of them exist on this graph intentionally, so we can kind of see how they would each give us a low point or a high point. All right, 4. This is the first time I've done this. If you've done some of the problems out of the book, they've asked similar style of questions, but you're looking at an original function. So to find the first derivative, it's easy, it's the slope. To find the second derivative, you have to understand that is the concavity. So if you were looking at the -4 value right here, what I'm trying to get at, so let me try to shade this in here. Which one shade? This one. Notice in this interval here, hopefully we all agree that original function is concave down within that interval. After that point, I'm concave up through here. So if I ask you where does the second derivative have a positive value, it's anywhere that it's green right now, at least initially what I have shaded, because we're concave up. We're concave down from a -7 to a -4, so therefore our second derivative would have to be negative in the pink interval. What I'm then specifically asking you about is this point, and what I'm intending for that to be is the point where we change from concave down to concave up. So that would have to mean that's our point of inflection. And then we know that that means the second derivative value has to be a 0. That point where we change from concave up to concave down, that's our point of inflection. All right. Okay, I'm going to give you like 2 or 3 minutes. Answer all of these now. These are what we've certainly done a number of these. So see if we can go through all of these. All right. I do want to point out one thing. It's a derivative graph, and you don't have to worry about your endpoints being a max or a min. It's an open interval with parentheses, so you don't have to worry about if your endpoints are a high point or a low point. All right, give you about 30 more seconds. Let's see where we're at. There's one on the back page I want to make sure we get to. Actually, there's 2 on the back page I want to make sure we get to. Let's see what we got here. Number 5, I want to know, without having to worry about your endpoints because of the parentheses, if it were brackets, you need to be concerned about them. Where are all the x coordinates where you're going to have a relative max on the original function? So Ryan, what'd you get, Ryan?
1.
Good. Good. Should be at x equals 1 because that's where the derivative graph is changing from positive values to negative values. Which means Aaron, what'd you get for number 6, Aaron? Good. The opposite's happening at the x value of a -1 because our derivative is going from negative values to positive values. That's what we have to do on our calculator. We did that a number of times the other day. Hopefully we can do those. 7, name all the x coordinates where the point of inflection on the graph of f would exist. So now this is a second derivative idea. So ideally that probably means the second derivative is 0, but more importantly it's changing signs. So the second derivative would have to be the derivative of f prime, which would then mean the slope of f prime. That's the second derivative, and we need that to be a 0. How do you feel about this one, Safian?
0 and 2.
Good. Should be at 0 and 2. Those are the places where we get nice horizontal tangent lines, and the second derivative there would have to be a value of 0. All right, number 8. Let's see. What do you think, Lily? Confident with this?
I put 0, 2.
Decreasing. Okay. No, I'm glad you said that. So what we said here, where's the shading one? This guy. So we said from here to here, the graph that we are looking at definitely decreases right there. But the issue with this is f prime. We want to know where f is decreasing. So if that was the graph of f, then absolutely 0 to 2 is where the original function is decreasing. So what we want to ensure here now, for our function to decrease, if I'm looking at a derivative, I need my derivative to be negative. That is the derivative graph. So where that's going to be negative is when it's underneath the x-axis. So in here and in here is where the derivative is going to take on negative values. So those are the intervals where we would be decreasing on the original function. All right, so that should be what? -2 through -1. And then from 1 through 3. All right. And then number 9, same idea with the concavity stuff. We want a second derivative for this. We would like our second derivative to be positive. The second derivative is the slope of the first derivative. So if we look anywhere over here, this whole interval here, the slope of f prime would be positive. And anywhere over here, the slope of f prime would be positive. So we should have had 2 intervals for concave up from a -2 to 0, and then from 2 through 3. Oops. Try that again. All right. Absolutely going to get one of these, or here's a derivative graph. I'm going to ask you a whole series of questions. We've got a number to model off of now. Make sure we can handle all of those, okay? And know what graph you're looking at. All right, is it an F graph or an F prime graph? Yes.
What do you use brackets or parentheses?
So because up here, see our original interval here? The -2 and the 3 are not defined in our domain on this. So that is why down here, for the -2 and the 3, I use parentheses because it's not actually in the domain of our function in this case. But with increasing and decreasing, we're always going to use these brackets if it's actually defined. Okay. Yep. I think that's what somebody else just popped up on the screen too and asked. So hopefully that answered both of you. Yeah, good question. Okay, last page. The ones I want to do are 10 and 11. And then if you can do the others, feel free. But It says the graph of f prime is shown. Use that graph to answer 10 through 13. So number 10, if the point 0, 4 is on the original function, write the equation of a line tangent at 0, 4. So we've done one like this. We've always talked about with a point or the line tangent, you need a point. That's flat out given to you at 0, 4. And then the other thing we always need is the slope. The way we always do our slope is we find our derivative value at the x coordinate of the point where we're tangent. So in this case, it's 0. So find that. What is f prime of 0? All right. Again, that is f prime. Those are giving you the values of our derivative at any x coordinate that we want. So if we look at the x value of 0, the value that that graph is giving us is a negative 2. So that is the value that we're going to use for a line. If you put 0, 0 is the value of the second derivative because that's the slope of the slope. Okay, so once we have that, we can now do y minus a 4. We know our slope is 2, and then x minus a 0. Okay. All right, so then now the next one. I'm either be giving you a table, I'll give you a bunch of information, or I'll give you a graph. Typically, I have them graph one without a calculator. Just from an equation, you've got to find all that. That's not really conceivable now because I can't tell if you have a calculator out or not. So I'm either going to give you a graph, I'm going to give you a table, or I'm just going to give you a bunch of criteria. You need to make sure that you can do this tomorrow. So what we're going to do, draw in as best you can. I'm going to draw an x-axis the same length as the one that I drew above. So -3, -2, -1, 0, 1, 2, and then 3. And then we'll say we start here. It doesn't matter where you start. You don't know where you start unless I give you a particular point, but we're going to say we start on the x-axis. And then the same thing now I've been asking you every time we do one of these, do we go up, down, or straight across right from the beginning? So what I'm going to do instead, let's kind of do it this way. Let's do it by intervals. Let's go from a -3 to -2. The two main things we need to know, are we increasing or decreasing? And are we concave up or concave down? So just look at the derivative graph between a -3 and -2. And however, if I have it, I'm going to circle the ones that I think. Am I increasing or decreasing? And then am I concave up or concave down within that interval? Okay. So if we look at the -3 to -2 on the derivative graph, the fact that the derivative is above the x-axis means the derivative takes on positive values. So that should tell us that we are going upwards. So we're going to be increasing. And then look at the pink little region there, the -3 to -2. The slope of that is your second derivative. And we have a negative slope on the graph of f prime. So that tells us that our second derivative is negative. Wait, do I have two concave ups? I do. I'm going to go concave down here. That means we're going to be concave down. So now we would draw that between a -3 and -2. We're going to increase and be concave down. So something like this. All right, the next one. Let's do between a -2 and 0. And then it's the exact same idea. If I now go from a -2 through 0, we want to know, are we increasing or decreasing? And are we concave down or concave up? All right, give you a little more time here, but we're getting a little short on time. The green region has a derivative. It's the derivative graph. It's underneath the x-axis, so that means our derivative has negative values there. So we have to start to decrease. The slope of f prime is still negative. So the fact that the slope is still negative means the second derivative is still negative. We are still concave down. So now between a -2 and 0, I'm going to continue to decrease, and I'm going to be concave down. So something like this. Doesn't matter where you cross the x-axis. So if you cross at 0, that's not wrong. If you cross sooner, it's not wrong. But we should be decreasing and concave down. All right, I'm going to hustle. So then what other color I got here? Would be yellow. So then now if I go from 0 to 2, here, same exact thought process. Between 0 and 2, notice how the derivative graph is still underneath the x-axis. So that means f prime is negative. So that means we've got to be decreasing. However, the slope of f prime is now positive. So that means our second derivative is now positive. That means we are concave up. So I'm going to have to move my paper here because I'm going to continue to go downwards. So starting at 0, I've got to continue to go down, but now I've got to be concave up. So now think kind of a parabola opening upwards until I hit 0. Here. And then finally, between 2 and 3, this last little interval, I'll leave it black in there. Your derivative has gone above the x-axis, which means now the derivative is positive, so the original function increases. The derivative still has a positive slope. That means your second derivative is positive. That means we're concave up. So now we're going to increase, concave up, and then that's our graph. Okay, as long as it looks something like that, we would be good. All right. Actually, then 12, since we're short on time, we can actually answer that now, because just look at your graph. It should be very obvious. When it asks where is the absolute lowest point on that graph, it's got to be right here at the x value of 0. All right. Yeah, concave down, we've already answered that, I suppose. Just look at your graph. It's got to be from a -3 till 0. Oh, that's a 2, isn't it? I can't read my own writing. Sorry, everybody at home. Yeah, it's definitely a 2. Bam. Yeah, thank you. Yeah, x equals 2. And then we're concave down from -3 to 0. That one's good. No solution. All right, and then 14, real quick. You've got to be increasing. So this tells us to be increasing. This tells us we are concave down. So the only one that is increasing while also being concave down should have been letter A. Oh, perfect. Okay, so Wednesday, if you have any questions, reach out, but quiz on Wednesday. All right, so look this over, and yeah, I'm glad we got it all done. Yeah, you don't really know the points to go through, so that's not